The universe is alive with invisible forces. Electromagnetism is one of these fundamental forces. It governs the interaction of electrically charged particles. This interaction creates electric and magnetic fields. These fields can store energy and do work. One fascinating aspect of electromagnetism is induced EMF, often referred to as induced voltage. This phenomenon is the generation of an electrical voltage in a conductor. This happens when the conductor is exposed to a changing magnetic field. Induced EMF is not some obscure scientific curiosity. It is the foundation of many technologies we rely on daily. Think about electricity generation. Power plants use giant generators. These generators rely on induced EMF. They rotate coils of wire within powerful magnetic fields, generating the electrical energy that powers our homes and cities. Understanding induced EMF unlocks a deeper understanding of how our technological world works. Imagine a simple coil of wire. Now picture a magnet at rest near this coil. Nothing much happens. The magnet creates a magnetic field, but because it is static, the magnetic field does not change over time. There is no flow of electrons in the coil, no electrical current. The magic begins when we introduce motion. As we move the magnet towards the coil, something remarkable happens. The changing magnetic field interacts with the electrons in the wire. This interaction forces the electrons to move, creating an electrical current. This current is induced EMF in action. The faster we move the magnet, the greater the rate of change in the magnetic field, and the larger the induced EMF. This phenomenon isn't limited to moving magnets. We can also keep the magnet stationary and move the coil. The relative motion between the magnetic field and the coil is what matters. Whether we move the magnet or the coil, the result is the same. Induced EMF generates an electrical current. The universe loves balance. Lenz's law embodies this principle in the world of electromagnetism. This law states that the direction of the induced current creates a magnetic field that opposes the change in the original magnetic field. In essence, the induced current tries to maintain a status quo. Imagine moving the north pole of a magnet towards a coil. The induced current will flow in a direction that creates a magnetic field with a north pole facing the approaching magnet. This opposition creates resistance. Lenz's law reminds us that the universe constantly seeks equilibrium, even in the realm of electromagnetic induction. In conclusion, induced EMF is a fundamental concept in electromagnetism. It is a beautiful dance between magnetic fields and conductors that results in the generation of electricity. Understanding this dance is key to appreciating the workings of generators, transformers, and countless other technologies that shape our world.